Hello, class. Today, we're looking at an algebra problem from the SAT that deals with negative exponents. We are given two variables, j and k, defined with these tricky-looking fractions. Our job is to first find the simple numerical value for both j and k, and then multiply them together to get the final answer for jk. Let's break it down. All right, let's start with j. The first step is to simplify the expression for j, which is given as 1 divided by 4 to the power of negative 2. The most important rule to remember here is the negative exponent rule. As you see on the screen, a number raised to a negative power, like x to the minus n, is the same as 1 over that number to the positive power. So 4 to the power of negative 2 becomes 1 over 4 squared. This turns our expression for j into 1 divided by the fraction 1 over 4 squared. Now we just need to calculate. 4 squared is 16. So we have 1 divided by 1/16. Dividing by a fraction is the same as multiplying by its reciprocal. The reciprocal of 1/16 is 16. So j is simply 1 times 16, which gives us 16. We've successfully simplified j. Next up is k. The process is very similar. The expression for k is 3 divided by 2 to the power of negative 1. We'll apply the same negative exponent rule. 2 to the power of negative 1 is equal to 1 over 2 to the power of 1, which is just 1/2. So our expression for k simplifies to 3 divided by 1/2. Just like before, to divide by a fraction, we multiply by its reciprocal. The reciprocal of 1/2 is 2. So k is equal to 3 times 2, which gives us 6. Great! Now we have the simplified values for both j and k. We're in the final stretch now. Step 3 is to calculate the product, j times k. We found that j equals 16 and k equals 6. All we have to do is multiply these two values together. As you can see, we set up the multiplication. J times k equals 16 times 6. Performing this calculation, we get 96. So the value of jk is 96. So we've found our answer to be 96. The last thing to do is to match our result with the options provided in the question. Looking at the choices, we see that 96 corresponds to option D. Therefore, the correct answer is D. This problem really highlights how a seemingly complex expression can be simplified by applying fundamental rules one step at a time. Remember that negative exponent rule. It's a common topic on the SAT. Great job working through this one.